This is our first lesson on hypothesis testing. We mentioned the concept of testing before. Testing is a statistical situation where we're looking for perhaps a difference between two groups in some characteristic, or maybe a relationship between two variables. So let's take a look at an example of the kind of thing we would see in a study that had been conducted using a hypothesis test. So this is typical of the sort of statement we might see at the conclusion of such a study. We can see here the claim is that rugby players are more likely to sustain broken noses than soccer players. This conclusion would have been reached after gathering statistics from a sample and studying those statistics and then determining whether or not those statistics would indicate that in general rugby players are more likely to sustain broken noses than soccer players. And like our estimates when we were doing confidence intervals, there's always a chance that any conclusion reached is incorrect, but what we'll be able to do is determine the probability with which we can believe the statement we see. So when we're looking for a situation for testing, of course, we mentioned before, one characteristic is a comparison between two groups in some characteristics. So here we're comparing rugby players with soccer players. And the variable that we're interested in is the number of broken noses. And so that's one thing that would clue us off that we have a hypothesis test, that we have two groups, and one group in some sense comes out ahead of the other group. I don't know if we would call having broken noses being ahead, but anyway, the other thing that would indicate to us here that we have a hypothesis test is when we see this kind of a statement. This is a statement about something we call a p-value, which we'll discuss in the next lesson. So anytime you see this p less than something or other, or p equal to something, then that indicates that a hypothesis test has been done. The p's that you'll see, sometimes they'll be lowercase, sometimes be uppercase. There is no consistency in that regard. Now, whenever we have a conclusion from a hypothesis test that we're trying to analyze, or whenever we're looking at conducting a hypothesis test ourselves, there's this concept of what we call the null hypothesis and the alternative hypothesis that are very important. Essentially, the null hypothesis is that we begin a study, such a study, or the researchers do, assuming that there's no relationship or no difference. And they can only claim that there is if their data indicates without a doubt or with very, very little doubt that difference occurs or exists, or that the relationship does. This is very much like in a court of law, where we hope that anybody that's on trial, especially if it's us, ourselves, is presumed to be innocent, and we only conclude that a person is guilty if there's enough evidence, if there's undeniable evidence, essentially, that the person is not innocent, in which case then we conclude that they're guilty. Recall that if when we are in court, there's a verdict of either guilty or not guilty, and the same sort of thing holds here. Anyway, we want to determine what the null hypothesis and alternative hypothesis are. Again, the null hypothesis is that there is no relationship or there is no difference. So in this case, our null hypothesis would be that rugby players are not more likely to sustain broken noses than soccer players, and that hypothesis is shown here. And then, of course, the alternative hypothesis is the thing that either was concluded or that we're trying to investigate and see if it's true. So the alternative hypothesis in this case is that rugby players are more likely to sustain broken noses than soccer players. So again, the null hypothesis is that there is no difference or there is no relationship. The alternative hypothesis is that there is some difference or there is some relationship. Let's look at a different example. In this case, the conclusion reached is that there's a relationship between genders and majors of students in Math 243. So in this case, what we're doing is we have two variables, gender and major, and we're looking for a relationship between those. We'll do that later with something called a chi-square test. But we would begin such a study by assuming that there is no difference or there is no relationship between genders and majors of students in Math 243. So that's our null hypothesis. And it's stated here. Now, mathematicians are as lazy as anybody else, or statisticians as well. So what they decided is we use this notation H sub 0 for null hypothesis to save us from having to write those words all the time. So we'll use that, and you'll see that perhaps. The null hypothesis is denoted by H0, and in this case the null hypothesis is that there is no relationship between genders and majors of students in Math 243. So the alternative hypothesis is then, of course, the opposite of that, that there is a relationship between genders and majors of students in Math 243. And we denote the alternative hypothesis with an H sub 1. So we'll use that notation as we move on to our final example. And this example is again about students in Math 243. I just made these things up, so you shouldn't take any stock in them, but I'd say this one is likely true based on my experience, but I haven't done a study. So the conclusion here is that there's no significant difference between the average Math 243 scores of psychology majors and communication majors. Okay, so we were looking to see if there was a difference between those two groups, and the conclusion here was that there was in fact no difference. Notice here the p-value is stated this time with a capital P. It was in our last example as well, so as I told you, you could have either a lowercase p or a capital P indicating the p-value. So in this case, they concluded there was no difference. That, in fact, validates the null hypothesis, which is, I shouldn't say validates, it just says that our assumption that there is no difference can't be proven to be wrong. So again, we would go into this assuming that there was no difference between Math 243 scores of psychology majors and communication majors, so that would be our null hypothesis. Our alternative hypothesis would be that there is a difference between the average Math 243 scores of psychology majors and communications majors. Now, if we went in thinking ahead of time that one or the other of those majors actually had higher scores, we would use that as our alternative hypothesis. The difference we'll see when sometimes we assume that one is going to come out, quote, ahead of the other, one group. In that case, we call that a one-tailed test. Or in a case like this where we look to see if there's a difference, but we don't know which way that difference would go, this would be called a two-tailed test, and we'll spend more time on that later. So this concludes our first lesson on hypothesis testing.